Hey guys, and welcome back for the last video of my 10-day algebra series. Today we are going to be looking at linear inequalities. So how to graph them and then how to solve systems of linear inequalities will be towards the end of this video. So starting with graphing, you'll notice in these first two examples, they are in my y equals mx plus b form, where b is your y-intercept and m is representing your slope. If you do not know how to graph a line, go back and watch that video. I will link it. And then that's exactly how you're going to graph this inequality, and then we're going to have a couple added steps at the end. So I'm starting by graphing this just like it's an equation. I'm going to find my y-intercept at positive 2. That's going to be my first point that I plot. And then I'm going to use my slope of 3 to go up 3 to the right one or down 3 to the left one. All right, then you can connect those points to make your line. However, since this is an inequality instead of an equation, we have to pay attention to that sign. It's not an equal sign, it's greater than or equal to, which means it is going to be a solid line because it could be anything on that line. All right, however, if it's just greater than or just less than, there's not that equal to in there, we're going to end up doing a dashed line because it could not land on that line. And then our last step with graphing these is deciding which side are we going to shade. So you can plug in any point. However, 0, 0 is always going to be easiest to plug in because anything times 0 is 0. So I am just plugging in 0, 0 into this inequality, and I'm getting 0 is greater than or equal to 2. That is not true, so it is not a solution, so I would want to shade the opposite side of my line. If it did work out to be a solution, then you would want to shade the side that that point lies on. And same thing with this second one, just to show another example, we're going to start at negative 2, and then we're going to use our slope of negative 1 to go down 1 to the right one or up 1 to the left one. Since it is equal to, again, it is going to be a solid line, and then it's plugging in to decide which side to shade. It is important to note that these were given to me in slope-intercept form. If it was not, you'd have to get y by itself first to do this, which I'll show you an example of that at the end of this video. So then I'm just plugging in my 0, 0 to get that 0 is less than negative 2, which again, this one is not true. So I'm going to find where 0, 0 is. Since it is not a solution, I am going to shade the opposite side of my line. Now that we have that down, we're going to move on to systems of linear inequalities, which, unlike equations, there is only one way to do this, and that's graphing, because you're going to have so many different answers. There's just, the only way to show that is with a graph. So just like I was doing with those previous two, I'm going to graph this by putting my first point at a positive 1, and then using my slope of negative 2/3 to go down 2 to the right 3 or up 2 to the left 3. All right, notice this time it is not equal to, it is less than. So we have to make this a dashed line. It cannot be on that line. Our solution is anything either above or below. We're about to test that out, but it cannot be on that line. Okay, remember to test it out, we're going to plug in 0, 0 as long as it's not going through 0, 0, which anything times 0 is 0 plus 1, we get 0 is less than 1. This one does work out, so wherever 0, 0 is, I want to shade that side because we know 0, 0 is a solution. It should be shaded in. All right, moving on to your second line, you're just going to do, or not line, I guess, inequality. You're going to do the same exact thing. Plot it at negative 2, our y-intercept, and then use our 1/3 slope. So up 1 to the right 3 or down 1 to the left 3. If you need a review on this, go back and watch that graphing video. This one is less than or equal to, so it is going to be a solid line because it could equal anything on that line. All right, and then again, we're going to test out our favorite point, 0, 0, because anything times 0 is 0, and we get that 0 is less than a negative 2 or less than or equal to a negative 2. Which we know that is not true. So we would have to shade the opposite side of where 0, 0 is. So below the line we're going to shade in. So if we're looking for solutions of these systems of linear inequalities, that's going to be where they overlap, all right, the solutions they have in common. So if you see where that purple and the blue both cross over, all of those are solutions. Okay, I know that was a lot, so let's take a look at it with another example. All right, this time we're starting at positive 2, and we're using a slope of 1/2 to go up 1 to the right 2, or down 1 to the left 2. Since it can be equal to, we're going to want to make sure this is a solid line, and then we're going to, again, plug in 0, 0, see if it is a solution or not. If your line was going through 0, 0, you could not use that to try, so you'd have to try something else that it's not going through, so like 1, 1, 2, 2, 1, 7. It can literally be any point. I just always test 0, 0 because, as you guys have seen, it's the easiest to plug in. This next one's a little more interesting because it's x. So if you think of if this was x equals -2, right, we'd have a straight up and down line at -2 because no matter what y is, x is -2. So no matter what y is, x is going to be greater than -2. And again, it's not equal to -2, it's anything greater than -2. So it's a dashed line, and then you can probably figure out, right, anything bigger than -2, we're going to be shading to the right, but I did plug in 0. I saw that it worked. It is a solution, so I would want to shade that side that 0, 0 is on. Right, now for the solutions, it is anywhere these two shaded pieces intersect. So we've got that straight line, and then that dashed line, and then all the points that fall in between there. All right, and now for our grand finale, I'm going to start with two inequalities that are not in slope-intercept form. I'm going to put them in slope-intercept form, and then get their solutions. So to get into slope-intercept, we want to get y by itself. So I'm starting by subtracting x from both sides, so that I'm left with 3y. And then since we want y by itself, we have to divide everything by 3. So that's going to make it y is greater than, and then there's that negative x, which is like a -1 in front. So it'd be like a -1/3 x, plus 6 divided by 3, we would get 2. Now from here, it's just like all those previous ones we've done. We're going to graph our y-intercept at a positive 2, and we're going to use our slope of -1/3 to go down 1 to the right 3, or up 1 to the left 3, and then connect those points. Since it can be equal to, it is going to be a solid line, and then we're going to test a point, usually 0, 0 if you're me, and figure out which side are we shading, which side has the solutions. So if I plug in 0, 0 here, I get 0 is greater than 0 plus 2. So 0 is greater than 2, which is not true. So that means we're going to want to shade above the line. Moving on to our second inequality, we're going to again start by subtracting off our x's. That leaves us with -3y is greater than, and then I'm going to put my x's first since we want it in slope-intercept form, so -2x, and that's a positive 3, so plus 3. Then from here, we have to get rid of that -3 by dividing everything by -3. That's going to cancel out so that I'm left with y. However, whenever you multiply or divide both sides of an inequality by a negative, you have to flip your sign. So instead of greater than, it's going to become less than. And then we've got 2/3 x, since they were both negative, we're just going to make them become positive. And then 3 divided by -3, we end up with a -1 as our y-intercept. And then going up 2 to the right 3, or down 2 to the left 3. So you notice they actually have an intersecting point there at 3, 1. This one is not equal to, so we are going to have a dashed line. And then lastly, we are going to decide which side are we shading, above or below. You can always plug in, you guessed it, 0, 0, which I get 0 is less than -1, which is not true. So I'm going to shade the opposite sides. So since 0, 0 is above, I am going to shade below the line. All right, remember their solutions are everywhere they intersect. So you can see this little kind of triangle to the right there is the piece where they cross, so that little bit right there is the solutions. But remember, these lines are going on forever and ever, so there are actually way more solutions than it may seem in this picture. So just keep that in mind. I hope you found this video helpful. If you did, please give it a thumbs up and make sure you subscribe so you don't miss any future videos from me.